Yes, good morning everyone. मम्मी मम्मी ये मोबाइल कोड ये मोबाइल Okay. Good morning everyone. Myself Priya and I'm a top educator in the category of EAMCET. I have been teaching on Unacademy platform from past 4.5 months, and I take classes for different other category of students like JEE, NEET, and even other categories like CET also in the offline mode for my students in colleges from 4.5 years. And under my guidance, I have produced very good number of rankings for not only CET but also JEE and also NEET category of students. So that's my experience of class, and this is about the YouTube live session and Unacademy Plus subscription plans. So these are the different plans you can see here. Plus subscription has been provided to you people on Unacademy platform. So the plans are 12-month plan. So the 12-month plan costs you around 12,375 rupees. There is a 6-month plan. The 6-month plan costs you 10,125 rupees. And also there is a trial price, and this trial price is applicable only for the new subscribers, and it is meant only for 2,250 rupees. In just an affordable price of 2,250 rupees, you can actually take benefits of plus subscription on Unacademy platform. So you can see in this plus subscription you also have EMI options. Like the 12-month plan, you can pay 1,031 rupees per month also, and the 6-month plan you can pay 1,688 rupees per month as well. So you can also go for the EMI options, and we can use this code PRKLIVE. You can use this code PRKLIVE to get additional 10% off on any of these subscription plans. So if you use this plans that are visible in front of you. So under this subscription plan, you will be having different benefits, like there is a comprehensive batch which will be live for complete syllabus preparation, and under this plus subscription you will be getting premium content at very affordable price. Structured live courses will be there. Live doubt clearing sessions will be organized. Quiz will be organized at regular intervals for self-analysis. There will be batches for complete preparation of the subject. Daily practice papers will be provided, that is DPPs, and full-length mock test will be conducted to analyze your subject knowledge. And under a single subscription, you will be having unlimited access to the content on Unacademy platform. So all of you can go for this plus subscription and make the benefits out of it, and learn from the very best educators on this platform of Unacademy. And you can follow my profile as well on Unacademy, which is available, the link to which is available in the description box. So you can just go to the description box of this particular video and find the link to my profile. So my next live YouTube session, as I have discussed here, I'm telling it right now only, that it will be on 26th at 8:30 a.m. and there I'll be discussing about top colleges after EAMCET. So moving on to the next one, that is, this is the topic for my next live YouTube session, that is top colleges after EAMCET. Here you will be getting complete details on colleges that accept EAMCET scores and ranks. So let's crack EAMCET and join the best colleges. So about that I will be giving the next live YouTube session, that is on 26th of this particular month. So this is about EAMCET Rankers batch. All of you can go. This batch has been conducted by Appaji sir, Maruti sir, Kiran sir and Arun Kumar sir. So you can join this batch also of EAMCET Rankers batch, which has already started on 24th December 2020. So let us discuss certain questions in this particular class, last class for this particular topic, and these are previous year MCQs on periodic table and periodicity in properties. So consider the isoelectronic species Na plus, Mg2 plus, F minus and O2 minus, and what they're asking us is what is the correct order of increasing length of radii. Increasing the length of radii. So first thing you should know is isoelectronic species. What is the meaning? Okay, what is the meaning of isoelectronic species? So isoelectronic species means what? So let me write it here. Iso means ions or elements having same number of electrons. Same number of electrons. So based on that we have to justify this particular question. Periodic trends in periodic table. So try to answer every question. Now whenever isoelectronic species are there, whenever we have isoelectronic species, you know, from left to right decreases, increases. So in this particular question, sorry, we have been given the elements. We have been given the elements as Na plus, also Mg2 plus, which is also same group element. So sorry, same period element. F minus is also same period element, and F minus is also same period element. All of them, they are same period element. So we can use this term like left to right, the size decreases as nuclear force of attraction usually increases, right? As nuclear force of attraction usually increases, and hence from left to right the size decreases. So what is the right order here? So we can see for isoelectronic species, ionic radii decrease with increase in nuclear charge, that is number of protons. Thus, for isoelectronic species, the cation with greater positive charge will have smaller radii, and anion with greater negative charge will have bigger radii. So here you can see Mg2 plus has highest, will be Na plus. Next to that F minus, then greatest negative charge will have greatest for this particular question. Let me tell you one more time that the one with the greater positive charge will have greater radius, sorry, smaller radius, because the one with greater negative charge will have greater radius due to number of protons. So this order varies due to number of protons, right? So let's consider the next question. Which of the following is not a actinoid? Not a actinoid. So you know actinoids, they usually range from element number 90 to 103. 90 to 103. So can anyone comment in the comment section what is the answer for this particular question? Yes, anyone? Yeah, definitely. If you know this atomic numbers, that is from thorium to lawrencium, the right answer is terbium. It is not an actinoid. Moving on to the next question. The order of screening effect of electrons of Spdf orbitals. Order of screening effect of electrons in Spdf orbitals. Yes, anyone? Third question. Which is more screened? You can comment the answers in comment section. Right answer, Yashoda, it's option A, because s orbitals, they are near to the nucleus. If I consider this to be the nucleus, then s orbital is near, then p orbital comes, then d orbital comes, then f orbitals. So the more screened or the more shielded shell is the s orbital or s shell. Next question. The first ionization enthalpies of sodium, magnesium, aluminium and silicon are in the order. So what is the order for this particular ionization enthalpies? First ionization enthalpies. So if you see what is the right answer, can anyone comment in the comment section? One of you for fourth question. Okay, right answer Yashoda. It's option A. You know, as you move from left to right in periodic table, left to right in periodic table, size will decrease. We know these all are second period elements. All of them, they are second period elements like sodium, magnesium, aluminium, and let us see silicon also, that is 14th 14th element in the periodic table. So based on this particular assumption that they are from assumption, or in the sense I can say they belong to second period only. So based on this particular theory, we can say that the right option for this particular question is option A. How? The ionization of enthalpies of magnesium here, you may feel that the order should be silicon, aluminium and sodium, but this is not the right order. The order sodium is least, then magnesium is highest, more than even aluminium. What is the reason? The magnesium having greater ionization enthalpy greater than aluminium. What is the reason? Can anyone comment in the comment section? Welcome Rock, thank you so much Satvik for joining. I hope you are following me on Unacademy platform as well, where you can find my n number of videos on different topics that I have taken so far. Okay, so as we move from up across a period from left to right, nuclear charge increases and therefore atomic size decreases. That's what I told. Hence ionization enthalpy increases. For aluminium, if I write, the electronic configuration is 3s to 3p1, outermost electronic configuration. Whereas electrons here are removed from 3p if you are taking the first electronic configuration, first ionization enthalpy. But magnesium is, in magnesium it is, right, magnesium it is removed from 3s2, where you can see 3s2 orbital, it is fully filled. It is fully filled orbital. If it is fully filled orbital, removal of an electron from stable or fully filled orbital requires more energy than removal of an electron from some other electronic configuration. Therefore, Why magnesium has greater ionization enthalpy as compared to that of aluminium? I hope all of you understood this concept, right? Moving on to the next question. Okay. The correct electronic configuration of gadolinium with atomic number 64 is, which is the right option? Can anyone comment in the comment section? Yes. Yeah. Yes, right answer, Yashoda. It's option C. Option C for this particular question. How? Just see here. The electronic configuration of lanthanum with atomic number Z is equals to 57. Right? Z value is equals to 57. So here it will be xenon 54, 5d1, 6s2. Therefore, further addition of electron occurs in a lower energy orbital, that is 4f orbital, till it is exactly half filled at EU, that is europium, okay, with atomic number of Z that is equals to 63, right? Okay, now here EU has electronic configuration XE 4f7 6s2, 4f7 6s2. Therefore, addition of next electron doesn't occur in more stable exactly half filled configuration, but occurs in a little higher orbital, that is 5d orbital. Therefore, gadolinium, which is represented by GD with atomic number Z is equals to 64, will occur in the next higher orbital, that it is half filled configuration, so it doesn't want to disturb it. So it would be 4f7 5d1 6s2. So as we discussed, it is option number, what we say is here, option C. Okay, moving on to the next question. The statement that is not correct for periodic classification of elements. So all of you can read the statement and try answering this particular question. Yes, everyone, you can answer the question right there. Yes, quickly, all of you can answer this question. Question number 5. All of you quickly answer this. Anyone? Sorry, 6. Question number 6. Statement that is not correct for periodic classification of element is, first option, let me just see the proper atomic numbers. They are asking us not correct. So this is correct. Non-metallic elements are less in number than metallic elements. That is also correct. For transition elements, the 3d orbitals are filled with electrons after 3p orbitals and before 4s orbitals. Yeah. Last option. The first ionization enthalpy of elements generally increase with increase in atomic number as we go along a period. That is also correct. So what's the wrong option here? Which is the wrong option? Quickly, anyone in the comment section, you can comment. Sixth question from this MCQ part. So as you see, this is also correct option. So for transition elements, the 3d orbitals are filled with electrons after 3p orbitals and before 4s orbitals. This statement is not correct. So first we fill 4s, then we fill 3d orbital. Next, among halogens, seventh question. The correct order of amount of energy released in electron gain enthalpy is. What is the correct order? Here I missed writing I, so you can just keep it as it is there. Yeah, seventh question. Which is the right order of electron gain enthalpy? Among the halogens, the correct order of electron gain enthalpy is. Yes, anyone in the comment section can comment the right answer for this particular question. Yeah, right answer is option C. What is the reason? See, electron gain enthalpy, it becomes less. Electron gain enthalpy becomes less negative and moving down a group. Why? Due to increase in atomic size, right? As you know, when we move from top to bottom in a group, size increases, but the electron is negative. Electron gain enthalpy of fluorine is less negative than that of chlorine due to electron-electron repulsion in small size of fluorine. And thus the correct order is option C. Okay, so you can just have values if you want for this. In fluorine, we experience a lot of electron-electron repulsion due to its smaller size. Therefore, these are the values just for your knowledge. Minus 328, minus 349, minus 325, and you can see minus 295. Here it is more electronic, more negative here. Okay, and therefore chlorine will be higher. Why? Because fluorine has a smaller size, and therefore due to small size there will be electron-electron repulsion, and hence due to that electron-electron repulsion, uh, chlorine will be having more electron gain enthalpy. Next, eighth question. Eighth question. The period number in the long form of the periodic table is equal to which quantum number? Okay. First one, magnetic quantum number of any element of the period, or atomic number of any element of maximum principal quantum number of any element of the period, or maximum azimuthal quantum number of any element of that particular period. So can anyone comment the right answer in this question? Yes, all of you. Yeah, right. So right answer here is option C. Option C. How? So any period is represented by the principal quantum number, which is represented also by n. So n is nothing but your principal quantum number. Okay. Now if I consider any example like magnitude 1s2, 2s2, 6, 3s2. So maximum quantum number is 3. Maximum quantum number is 3. And therefore here it belongs to third period. Belongs to third period of the periodic table. Okay. Any example, it will be same only. Even if you write k element configuration 2, 8, 2. N values 1, 2, 3. So here also it is in third period only. It shows in third period. Next question. The element in which electrons are progressively filled in a 4f orbital are called as 4f orbital. Very simple question. Ninth question. In which of them the elements are filled in 4f orbitals? Which series of elements? Yes, quickly you can comment in the comment section. Very simple question. So right answer is actually lanthanoids. In lanthanoids the electrons are filled in 4f orbitals. In actinoids we fill the electrons in 5f orbital. So right answer would be lanthanoids. For lanthanum generally we can say it is Xe xenon 4f 5d021 6s2. This is a general electronic configuration. You can write it in this manner also. N minus 2 F is N minus 021 and N is 2. N capital means small n, not capital N. So 6 is the n value here. So n minus 1 would be 5, n minus 2 would be 4. So that was the question. Last question. Okay, here one option has come up here. So just make sure it is an option. Which of the following is correct order of size? Correct order of size. So I had given you one particular statement before, one more question we had dealt, that the one with greater positive size charge, the one with greater positive charge will be smaller